Hello students, welcome to the another new lecture of the engineering chemistry course. As we are continuing with the unit 5 organic reaction mechanism and introduction of drugs. Before starting the today's class, just have a quick recap of the previous class. In the previous class, we are continuing with the topic addition reaction. In the last class, we have learned about the nucleophilic addition reactions, in which we have learned the mechanism of the nucleophilic addition reaction, and specifically we have considered the nucleophilic addition reactions in the carbonyl compound, in which aldol condensation reaction we have discussed in our previous class. In the today's class, we are continuing the topic addition reaction, as we have learned that the addition reactions are of three types: electrophilic addition reaction, nucleophilic addition reaction, and the free radical addition reactions. In the previous classes, we have learned about the electrophilic and the nucleophilic addition reactions. So today we are going to learn about the free radical addition reaction. In the today's class, we will learn about the mechanism of the free radical addition reaction with the peroxide effect or the Kharasch effect. Now, let us consider an important reaction, that is the reaction of 2-methyl propene with HBr in presence of the peroxide. We know that this is the unsymmetrical alkene. When attack of HBr taking place onto the unsymmetrical alkene, then we have learned that according to Markovnikov rule or Markovnikov addition, this hydrogen goes to the carbon atom which already have the higher number of hydrogen. So this hydrogen will attack on this carbon atom while the bromine attacks on this carbon atom. So according to Markovnikov addition, the 2-methyl propane will be the major product. But what happened when this reaction is carried out in presence of peroxide? It was observed that in presence of peroxide, the addition of HBr to unsymmetrical alkene takes place in an anti-Markovnikov manner, and this was discovered by famous chemist Kharasch, and this effect came to be known as the peroxide effect or the Kharasch effect. So basically, what is the Kharasch or the peroxide effect? It is that when addition of HBr taking place on to the unsymmetrical alkene in presence of peroxide, then that addition always taking place in the anti-Markovnikov manner. That means if Markovnikov addition says that hydrogen will attack first onto this first carbon atom because it has the higher number of hydrogen. So if this reaction is carried out in presence of peroxide, so this will happen in the anti-Markovnikov manner. That means now this hydrogen attacks onto the C2 carbon atom and this bromine will attack now onto the first carbon atom. So the major product will be this product. That means 2-methyl bromopropane will be the major product, while in case of absence of peroxide, normal Markovnikov addition taking place, and if normal Markovnikov addition taking place, that means in such case 2-bromo product is the major product, while in presence of peroxide always anti-Markovnikov addition taking place, and this effect is known as the peroxide effect or the Kharasch effect. Now the question comes to our mind, why it happens so? Why in presence of peroxide anti-Markovnikov addition taking place? This anomaly was explained by the free radical mechanism only. So let us consider the mechanism of the free radical addition reaction. The free radical addition reaction follows the chain mechanism which involves three steps. First, the chain initiation step. Second, chain propagation step. And third, chain termination step. First is the chain initiation step. In the chain initiation step, basically the peroxides which contains a weak oxygen-oxygen bond, this peroxide is the H2O2, hydrogen peroxide. So since this peroxide contains weak oxygen-oxygen bond, so by heat or light it undergoes in homolytic dissociation, resulting in the formation of 2 hydroxyl free radical. So in the chain initiation step, the peroxide undergoes homolytic bond cleavage. This is the Fischer-Hooke arrow. That means single electron moves towards the each hydroxyl group. So formation of the 2 hydroxyl radical taking place. Then this hydroxyl radical abstract the hydrogen atom from the hydrogen bromide. Again, the bond is breaking of this bond taking place with the homolytic cleavage. That means a single electron goes with hydrogen and second single electron goes with the bromide. So this will result in the formation of the bromine free radical. So this is the chain initiation step in which due to the homolytic bond cleavage of hydrogen bromide, formation of bromine free radical taking place. Next step is the chain propagation step. In this step, addition of bromine radical on carbon double bond carbon takes place. This is the double bond where the addition would takes place. Now, this bromide free radical attacks on this double bond. So, if this attacks on C1 carbon atom, let us give the numbering of these carbon atom. If this bromine radical attacks on the C1 carbon atom, so this will result in the formation of the secondary free radical, because if bromine radical forms the single bond between this carbon atom and bromine radical, so the single electron lies with the C2 carbon atom. So there is the formation of the secondary free radical taking place. While in case this bromine attacks on C2 carbon atom, so this will result in the formation of the primary free radical. And we know secondary radicals are more stable than the primary free radicals. Therefore, always bromine attacks to that carbon atom which contains the higher number of hydrogen atom, because this type of attacks leads to the formation of the more stable free radical. Okay, so as a conclusion, we can say addition of the alkene will preferably occur in such a way that the most stable free radical is formed. That is why bromine adds up on the least substituted carbon of the alkene. That means the carbon which has the higher number of hydrogen, always the bromine radical attacks to that carbon only, and hence it observed as the anti-Markovnikov addition, because now the bromine attacks taking place on the carbon 1 on the CH2, because this results in the formation of the more stable free radical. Okay, now in this step, formation of the secondary radical taking place. Now this secondary radical again reacts with the hydrogen, another molecule of the hydrogen bromide. In this next step, this hydrogen will form the bond between the with the carbon atom which has the single electron, and again this bromide radical is free for further reaction. So this chain propagation step continues in this manner. Next is the chain termination step. There are also termination steps, but we do not concern about the termination steps as they are just the radical combination to create waste products. For example, two bromine radical can combine to form the bromine. This radical addition of bromine to alkene by radical addition reaction will go on until all the alkene turns into the bromoalkane, and this process will take some time to finish. But our concern is mainly on to the chain propagation step, in which secondary radicals are formed which are the more stable radicals. That is why attack of bromine radical taking place onto the first carbon atom only, which leads to the anti-Markovnikov product. Some other important free radical addition reactions of alkenes are addition of polyhalomethanes, addition involving acyl radicals, addition of thiols and the thiocarboxylic acid. I request you all try to figure out the mechanism of these addition reactions with the free radical mechanism. Now, while considering the Kharasch effect or the peroxide effect or the free radical addition reaction mechanism, we must remember that while HBr in presence of peroxide can undergo free radical addition with alkene, no such mechanism has been observed with hydrogen fluoride or hydrogen iodide or hydrogen chloride, owing to the greater bond energies of these hydrogen halides. So, only HBr can show the peroxide or the Kharasch effect, because Hi has the lower bond energy than Hb, because the HCl and HF has the higher bond energy. That is why they do not undergo into the homolytic bond cleavage in presence of sunlight, while Hi has the lower bond energy than HBr, but the alkyl radical that forms by addition of iodine radical to the alkene is unstable and quickly loses the iodine radical to regenerate the alkene. That is why only HBr gives the Kharasch effect or the peroxide effect. Now it is time for the learning check. Read out the question on your screen and think for its correct answer. In which of the following will Kharasch effect operate? First is the reaction of 1-butene with hydrogen bromide. Second is the reaction of 1-butene with hydrogen chloride. Third is the reaction of 2-butene with hydrogen bromide. Fourth is the reaction of 1-butene with hydrogen iodide. Pause the video for a while and think for its answer. We will discuss its answer in tomorrow's live class. Now, let us revise what we have learned in today's class. In today's class, we have started with the free radical addition reactions. The free radical addition reactions of alkene involves 3 steps: initiation step, propagation step and termination step. You must remember that free radical addition reaction always follows the chain mechanism. In the chain reaction mechanism, there are the 3 steps: chain initiation, chain propagation and the chain termination. Second important point, that HBr in presence of peroxide react via a free radical mechanism to give the product with the anti-Markovnikov addition. This is due to the attack of bromine radical to the least substituted carbon and formation of the more stable alkyl free radical. So you must remember this step. this one. You must remember this step because in the chain propagation step, attack of the bromine radical taking place onto the alkene. So this attack will always favors the more stable free radical formation. Therefore, always the bromide radical attacks onto the least substituted carbon. That means the carbon atom which has the higher number of hydrogen. This is the first attack of the bromide radical, in which bromide always attack to the carbon atom which is having the higher number of hydrogen atom, or which carbon is the least substituted carbon atom. Because this type of attack results in the formation of the more stable free radical. That is why this attack takes place. Okay. Now, among the hydrogen fluoride, hydrogen chloride, hydrogen bromide and hydrogen iodide, only hydrogen bromide shows the peroxide effect because HF and HCl are having the higher bond energies than the HBr. That is why these two do not show this effect. But HI has the lower energy than the HBr. But the problem with the attack of HI is that the free radical formed by the attack of the hydrogen iodide or the iodide radical to the alkene is unstable, and this convert into the iodide and the alkene again quickly. That is why the HBr only shows the peroxide effect or the Kharasch effect. So that's all for the today's class. Thank you. Take good care of yourself and keep enjoy e-learning at home. Thank you.